Well, welcome everyone. This is going to be super fun. And if you haven't been to this program before, we mostly use a software called OpenSpace, which was developed in partnership with NASA and NOAA, several other organizations that stitch together satellite images. So as we go flying around the planet Earth, you'll be looking at actually what the planet Earth would look like in space. If you want to imagine you're in a spaceship, you're welcome to. That's how I like to watch the program. And so it's not a rendering or an animation. You're looking at actual data of what the Earth would look like from space. And we are ready to go. So officially welcome everyone to Digital Earth Academy Extremes. And first of all, I would just like to acknowledge that the Denver Museum of Nature and Science, where we're broadcasting from, is built on lands that have traditionally been stewarded by the Ute people, the Cheyenne people, and the Arapaho people, and that lands all over the planet Earth have been and continue to be stewarded by indigenous people. As you watch the program, we'd love to hear from you in the chat. If you have any questions or if our presenter asks questions and you want to answer them, that would be great. If you're in a classroom, if someone could be in charge of taking the poll of the temperature of the room and typing in the chat, that would be excellent. And you won't see each other's questions, but we will save them and we'll have some time at the end. And with no further ado, I would like to introduce our pilot geologist, Dr. Bob Reynolds. Take it away,
Great.
Bob.
Great. Thank you, Mitch. Thank you very much for joining us all today. And I want to remind everybody that we're coming to you from Denver, Colorado. And I see that we have an audience scattered from Alaska to Hawaii and to New York City. So welcome everybody. And we're going to give you a tour of many things. But we do hope that someday you'll come and visit us at the Denver Museum of Nature and Science, which is in downtown Denver. So my name is Bob Reynolds, and I'm a geologist. I study layered sedimentary rocks. I study climate. I study the history of the Earth. And as a geologist, I've had a wonderful opportunity to travel to many places, some of which we're going to talk about today. So I'll be giving you a geological point of view about the Earth. And the Earth, of course, is made up of rocks. It's made up of geology, and it's a wonderful place. So let's hop right in. The theme of today's presentation is extremes. And so we're talking about the biggest, the smallest, the hottest, the coldest, sort of the extreme characteristics of different places on the surface of the Earth. But we're going to start at the Denver Museum, and Asa is our pilot. He's flying OpenSpace, which is provided by NASA and NOAA. And we're going to start out at a place that'll be familiar to our Colorado viewers. But that building, which you're seeing from above, we're sort of at balloon level or drone level here. That building is the Denver Museum of Nature and Science. It's located in City Park in downtown Denver. And here you see us pulling away as if we're in a hot air balloon. You can see the solar panels on the roof, and you can see there's some parking spaces. As we move out a little bit further, you can see the zoo, for those of you who are familiar. The Denver City Zoo is there in City Park. And as we get a little bit further up, sort of at a high balloon level here, you can start to see some of the neighborhoods around the Denver Museum, some golf courses. And as we get up to maybe airplane level here, you start to see the downtown Denver, the capital of Colorado, and there's a big Capitol building there. Then you see the South Platte River. And now that we're getting up to high airplane level, you can start to see the region. And we're almost getting up to satellite level here, where you can start to see the Rocky Mountains and the fact that Denver is at the intersection of the high plains and the Rocky Mountains. And now as we get even further up, we're seeing much of the western United States. We're seeing Utah, we're seeing parts of Nevada, and we're seeing Salt Lake there on the west. But we're going to be traveling away from Colorado. We're going to go up to Wyoming, to the northwestern corner of Wyoming. We're going to cross the Greater Green River Basin, the Wind River Mountains, the Wind River Basin. We've got the Bighorn Basin, and we're going to end up in the northwest corner of the state of Wyoming. And we're going to go to our oldest national park. And our national park is celebrating its birthday this year. It's 150 years old. And the national park begins with a Y. And we're going to see it in the chat, people that know which park it is. Begins with a Y, and I see a guess from California, not quite right. There's another park that begins with a Y. And in any case, this one's got a big lake in it, which you're seeing, and we're going to be looking for some extremely interesting environments inside this park. And I will tell you its name. There you go. Charlotte has it, Carlotta has it. This is Yellowstone National Park. And it's got a very famous feature that we're going to investigate, which is an extremely interesting product of hot water and steam, and it's called a geyser. We're going to go to one of the largest geysers in the world, and it's a very famous geyser that some of you might have seen. And if you live in Colorado, you can get up to Yellowstone within a day and a half or a couple days drive, and you can see this place for yourself. We're coming down in on a very famous geyser. And some of you, there you go, Liv has the right answer. It's Old Faithful. Archer, you got it as well. So we're going to be seeing the Old Faithful geyser in Yellowstone National Park. And you can already see, I can see the visitors standing there waiting for it. We're going to zoom right in. Ace is going to put us right on the ground. And here we are looking at the geyser erupting, and we're at the visitors stand there. We're standing on the safe ground, looking across at the steam eruption. And this eruption comes up about every hour. It's a very systematic and faithful erupter. And Old Faithful is famous for its punctuality. They'll tell you about what minute it's going to erupt. Sometimes it's a little bit earlier or a little bit later, but you can stand out there and get ready for it, and then it will erupt right about on time. And it's a product of steam building up underground in very strange plumbing systems where the steam gradually fills up the plumbing and reaches to a point where it bubbles out with what's really a catastrophic eruption. And it's very exciting to see. And you can see the plume of steam and the water falling out. And it's a very dramatic event. I really encourage you to visit it yourselves and to see it firsthand. It's relatively easy to get to, and it's one of our great wonders here in the Western United States. We're going to look a little bit more around Yellowstone. Ace is going to back us out from Old Faithful, and we're going to look at some of the other hot spring deposits and other thermal features in the Yellowstone area. And you might wonder why there's thermal activity. Thermal means heat. Why is there heat activity in the Yellowstone area? And it's because Yellowstone is part of a giant volcano. And the volcano is dormant. Dormant means sleep. So the volcano is asleep right now. But we know as geologists that there's red hot magma not very far under the ground at Yellowstone National Park. And the Yellowstone volcano is asleep, but it may wake up sometime. And maybe not soon, but sometime in the future, there will be more volcanic eruptions in the Yellowstone area. And these hot springs and geysers are a manifestation of that hot rock, which is lying at depth underneath the Yellowstone area. We're zooming in now on another hot spot, hot spring area. This would be one of the more beautiful features that you can visit when you're on the ground there. This is the Grand Prismatic Spring. And there's a walkway. You can stay on the walkway and you can walk across the hot ground safely. And you can get right up close to these hot springs by staying safely on the walkways. And the colors are very beautiful. You can see them as you walk in. Here, Ace has landed us right on the walkway. We're looking across at the steaming pool of the Grand Prismatic Spring in Yellowstone National Park. And you can see the interesting colors. The central part is deeper, and that's the blue colors, in part reflecting the color of the sky. And then there's scattering from particles in the water that enhance the blue features of the interior part of the Grand Prismatic Spring. But the outer colors, particularly the yellows and the reds and the dark browns, are associated with a kind of bacteria that's called an extremophile. It's something that lives in very extreme conditions, in this case, very hot acidic waters. And these are archaeobacteria. They're very primitive kinds of bacteria, not the same live, for example, in our intestines, but these bacteria or archaeobacteria are very primitive, and they live in very, very extreme conditions, and they give the colors to the different areas of the rock and water surrounding these pools. Now you can see how the visitors to the pools are carefully standing on the boardwalk. The reason is very important because the ground is unstable and very hot. And it's possible if you step off the boardwalk that you might sink in to boiling hot mud. And that's a super dangerous thing around Yellowstone. So when you go, be sure to stay on the boardwalk. But there's some evidence here of some creature that didn't read the sign and went walking off into the ground here, see if you guys can see something that looks like footprints. And I think if you look closely, I can start to see footprints. They're sort of paired hooves. So there's something here with a paired hoof, which would be an artiodactyl, which has a paired hoof. And in this case, that's actually a bison. So an American bison, which is bison, walked off the boardwalk and into the mud. And fortunately for this bison, they had the sense to stay near the edge and not get into the deeper part. And I think the footprints go in and then come back, walking right back out again. So the bison survived. But as a geologist, I can tell you that every once in a while, an animal will make a mistake and will step into the hot mud and will sink and sometimes turn into a fossil. So that's the way some fossils form. We're going to back out from the Grand Prismatic Spring here at Yellowstone Park, and we're going to look for another very volcanically active area. We're going to travel now. We can travel around the world. So you're going to see us backing up here. ACE is taking us up to satellite level. We can see the western part of the United States on the sort of the left-hand side. You'll see California. And we're going to cross across the eastern US. We're going to cross across the North Atlantic, crossing Greenland. And we're going to come down to this little island on the east side of Greenland. And some of you might know the name of this island. Let's see if you can type in the name of this island, which is on the east side of Greenland. And I'm looking for the name of the island. Somebody might know it. There you go. Carlotta is good. She's got it again. So Carlotta has figured out this is Iceland. And we're going to come to Iceland. And Asa's family is actually from Iceland. So we're coming to Asa's home ground here, and he'll recognize the various details. This is a place where the Mid-Atlantic Ridge comes up above sea level. So the Mid-Atlantic Ridge, which is a mountain range that goes across the entire length and breadth of the world, the mid-ocean ridges cross all the oceans. And the middle of the Atlantic Ocean has a ridge on it. And it comes above water here in Iceland. And we can see that the Mid-Atlantic Ridge is made up of volcanic rock, in fact, made up of volcanoes. And as we come into the Reykjanes Peninsula here in Iceland, we're going to see evidence of that volcanic activity. We're located very near the airport, which is called Keflavik. If you fly to Iceland, not too hard to get there. Keflavik is a big airport, and it's on the Reykjanes Peninsula. And it's not very far from the capital of Iceland, which some of you might know the capital of Iceland, which is Reykjavik. And the kids in Reykjavik got all excited back last summer because there was a new volcano that formed here on the Reykjanes Peninsula. And it was so exciting that the kids were able to leave school and they grabbed their hot dog sticks and they came down to this volcano and they roasted hot dogs on the volcano. And we've got a little video clip of what the volcano looked like, and it was super amazing. And the little lava flow that's going off to the right-hand side of the screen flowed out, and the students from Reykjavik were able to get close enough to that streaming flow of lava to roast their hot dogs. And to me, it's a little astonishing because Iceland doesn't have a lot of trees. There's not a lot of sticks there. I've been to Iceland several times, and it's hard to find a hot dog stick in Iceland. So it might be they have metal sticks or something, but that's the volcano that was erupting there in Iceland on the Reykjanes Peninsula last summer. And I think it's probably still cooking along a little bit. I haven't heard a recent update, but that volcano is one of the youngest volcanoes on the surface of the earth, and certainly one of the most accessible, meaning you could get to it very easily. If we look at Iceland in a little bit more detail, you'll see that there's a series of white caps. Those are glaciers on the tops of the mountains in Iceland. And Iceland is famous for having lots of geothermal energy, and they also have hydro power. So Iceland has one of the greatest concentrations of renewable energy of any place on the entire planet. And it's because of the fortunate coincidence of the geothermal activity, which geothermal means earth hot. So they've got natural earth heat, and then they also have hydro, and hydro means water. And so they have hydroelectricity and geothermal electricity in Iceland. We're going to continue our discussion about volcanic areas. We're going to leave Iceland and we're going to go down to the African continent. And I study Africa. In fact, I just got back this week from a 1 month tour of working on the geology of the Rift Valley. So we're going to talk a little bit about what I work on, which is the geology of Eastern Africa. And we're going to start out in southern Kenya, which is on the eastern side of Africa. So you're seeing the entire African continent. The northern part is the Sahara Desert. The central part is the Congo Basin. And then there's a big circular lake, which is Lake Victoria. And the little lake, they're two like string beans. The one to the left of it is Lake Tanganyika, and the one to the south is Lake Malawi. And they're in the Rift Valley of Africa. And we're going to look at a particular lake on the northeast side of Lake Victoria in southernmost Kenya, and it's Lake Magadi. And it's a very, very interesting lake. It's got some extremely interesting biological things happening in very extreme conditions. The border between Tanzania and Kenya is right here in front of us. Lake Natron is the big lake in the middle, and it's in Tanzania, but the border is right there between them. And we're going to go to the little lake, which is actually in Kenya. And Kenya is a country in East Africa, as is Tanzania. And these countries are famous for the geology and also for the animals. There's lots of wildlife. And sometime if you get a chance, you can visit Africa. And I encourage anybody, of course, to have a chance to visit. And you can see wonderful, wonderful things in the national parks in East Africa. We're getting a little bit closer to Lake Magadi here. And you can see the ground is broken. They're sort of fracture zones or faults. And this is an area of active geology. The earth is pulling apart here in East Africa. The Rift Valley is opening up, getting wider every year. It's getting wider at about 2 to 3 millimeters per year, which is a little bit slower than your hair grows, but it's stretching apart. And this lake, Magadi, has this very unusual pink and reddish stuff in it, which is really some kind of an algae that grows in the extremely acidic and salt saturated waters. There's also brine shrimp that live in this kind of situation. And the flamingos come in here and they suck up the brine shrimp. And many of you have seen flamingos, and they have their beaks, they tilt their heads upside down and filter the brine shrimp out with their bills. A very interesting biological study. If any of you want to see a weird bird, look at a flamingo when it's eating its brine shrimp. You'll see it has its head upside down in the water. A strange thing to see. But this lake is in the Rift Valley, and I've been here from Nairobi. I actually came by taxi cab one time down to this lake, and the taxi driver and I drove all around. We went down to the very edge of the lake, and we didn't go in because the water is it's a strange chemical brew. But we certainly looked at the water's edge, and we looked also, they're mining some of the salt. The white stuff is a salt precipitate, and it's mined for sodium and potassium chemicals. So there's a mine right here, actually in this field of view is where the mine is. The people live in the little village on the right. There's some little houses there, and then the mine is right there, that big building. It's a very strange place to go because the dust is all over the place from the mining. They grind the stuff up and it makes dust, and it makes stalactites that hang from every pipe inside the building. It's a very interesting place to go visit. But this part of the Rift Valley is very easy to see from space. And if you use Google Earth, you guys can do this yourselves. You can pull up this kind of imagery yourself using Google Earth. But we're going to continue north in the Rift Valley, and I want to take you up to Lake Turkana, which is in northern Kenya. So we're going to go across Kenya from the south to the north. And I just got back from Lake Turkana, so I'm eager to tell you one or two stories about where I've just been. And I'm working on the geological maps of Lake Turkana. I've got wonderful computer maps. It's just the one on the upper left. Whoops. And it's on the upper left of the screen here. And it's got a very interesting greenish color. It's called the Jade Sea. And we might zoom into the upper part of it here once Asa gets re-equilibrated. And the reason it's called the Jade Sea is because it has that sort of greenish color to it. And it's in the middle of a desert. It's one of the largest lakes in a desert in the whole world. And it's a super hot desert. And I can tell you that one of my problems as I was working on my geological maps is it's so hot that you can't help but you're sweating and the sweat is dripping off your head onto the maps. And so it's one of the challenges of working there. Plus the wind's blowing. It's a pretty rugged place to work, but we had a wonderful time, and we worked on the west side of the lake, and we had some Kenya students from the Turkana University College, and we worked together with the students. We went up to the northern side on the west, and then we were going to cross the lake, and you can see an island up at the north there at the top. That's called North Island, and we set out from that peninsula on the left-hand side, that little bump, and we had a boat, and they put in a spare engine. It was about a 30-foot long boat, and they put in the spare engine, which I thought was helpful. And as we got out into the water a little ways, the main engine quit, stopped working. And so they put on the spare engine, and we got out to about where that island is. We were just on the north side of that island, and the spare engine fell off the boat. And fortunately, they had a rope on it, so it only went down a few meters, and then they hauled it back in, but it wouldn't start anymore because it was wet. And so we started paddling. And so we were paddling our boat across the lake, and I was worried we were going to miss supper because supper was set for 6 o'clock. And we were paddling frantically. And fortunately, that second engine dried out enough that it got started, and we made it across the lake in time for supper. And then we did a lot of work on the east side of the lake, which is the right-hand side here. And we looked at all those rocks, and you can see the different colors of rocks. And each one of those represents a different kind of sedimentary rock. They're full of fossils, full of stone tools. It's the most magnificent place to work. Lake Turkana, northern Kenya. But we're going to continue north. We're going to go up into Ethiopia. We're crossing along into the eastern part of Ethiopia, and we'll go up in towards Djibouti and Eritrea. The green lake on the center left there is Lake Tana. That's the source of the Blue Nile. We've got the Red Sea to the north and the Gulf of Aden on the right. And we're going down into the Afar Depression of Ethiopia and Eritrea. And we're going to be looking at a feature that's just north of the Erta Ale volcanic complex. That dark thing in the lower part of the screen is Erta Ale. It's an active volcano, but we're going to look at a hot spring deposit that's just up here to the north, and it's called Dalol. So we're going to go to this feature, which is very hard to get to. This is a place that I have not been to, and it's hard to get down into this area, difficult to find transportation. And then when you get down in here, it's super rugged, super hot, and it's a land where the Danakil people live, and they make a living by mining salt. And some of the white material in the image here is salt, and they break up pieces of salt and they carry it up to the edge of the Rift Valley, and they put it in on, they actually take it by camel. So the salt goes by camel up to the edge of the Rift Valley, and then they transport it all over Ethiopia. And I've ridden on buses in Ethiopia, and the problem on the buses is that they put the salt blocks in the overhead racks, and the roads are very rough. So you're bouncing along on these rough roads, and the salt bricks can bounce out of the overhead compartments and come crashing down. So you have to be careful not to get hit on the head by a brick of salt. And the bricks of salt are used because people need salt, and they actually take it home and they grind it up and put it in their salt cellars. But this area here, if we were to zoom in closer, you'll see that there's all kinds of gnarly terrain here. There's hot springs, and if you zoom in close, this is what it looks like. And this is one of the most acidic areas on the surface of the earth. The acids are coming from the rocks, and it's a very acidic environment. And the acids are natural in this case, but there's a variety of things that can happen with acid. And it might be that in a moment we can play the acid video. We're about near where we're talking about acid, and let's see if we've got a video that'll tell us about acidic conditions.
Hello everyone. Welcome to one of the Denver Museum of Nature and Science's science labs. Today we're going to do some experiments about what would happen to the human body in some of Earth's most acidic environments. In particular, we're going to look at what would happen to the hardest part of the human body, the teeth. And you're probably wondering, where did I get this bag of human teeth? Well, where else am I going to get it from? I got it from the Tooth Fairy. That's right, the Tooth Fairy. And we had permission to use these teeth from their previous owner.
These are from our friend Rohana. She lost them as a baby, but grew new ones, so she doesn't need these anymore.
Wow! Thanks, Tooth Fairy.
Anytime. If you ever need... Wait, did you hear that? Somebody just lost a tooth and put it underneath the pillow. I must be off. Goodbye!
Okay, thanks, Tooth Fairy. To simulate some of the hyperacidic pools in Dalal, Ethiopia, we have some hydrochloric acid. But first, let's see what would happen to your teeth in some more common acids. Here we have orange juice, a carbonated cola, vinegar, and water for a control. One way to measure how acidic something is with the pH scale. Water is at 7, right in the middle. The lower the numbers are, the more acidic they are. We can test this with litmus paper. When you dip litmus paper in a substance, it changes color and telling you how acidic it is. You can see that the orange juice is kind of yellowy orange. And the cola is a teensy bit redder than the orange juice. And the vinegar, which is actually a cleaning vinegar, so it's more acidic than normal vinegar, is a little more pink. Next, we measure the teeth on a very, very sensitive scale, so we can figure out exactly how much they corrode in the acid. Finally, it's time to put the teeth in the acids and begin our experiment. And then, we wait. So our teeth have been soaking overnight in the acids. Now we get them out of the acids, we'll dry them off a little bit, and then we'll weigh them, and finally, we get our results. All of our measurements are in grams. We see that the tooth that was in water changed mass by about 0%. That's what we expected. The tooth that was in vinegar lost about 12%. The tooth that was in cola lost about 16%. And the tooth that was in orange juice lost about 10% of its mass. Now this is just one experiment, and all of our teeth had different starting weights. To get really accurate numbers, we'd have to do this over and over again with lots and lots of different teeth. But these preliminary results suggest that the acid that's worst for your teeth, cola. Also, look at that tooth. It looks worse than the other teeth in a couple of different ways. Maybe there's something else in cola that's bad for your teeth.
It's sugar, which comes in many forms, like high fructose corn syrup. Beware!
But now it's time for the main event, the hydrochloric acid. So now let's check the pH of our hydrochloric acid. It is much redder than our other acids, much more acidic. In fact, to test this, I think we're going to need a bigger tooth. This is an adult molar donated by our curator of space sciences, Dr. Kachun Yu. Now we begin our experiment. We take the tooth, we put it into our scientific glassware, and we pour the hydrochloric acid over it. Now we've actually diluted the acid to about 40%, so it's safer to work with, but it's still extremely acidic. You can see the reaction is already taking place. We actually set up a time-lapse camera to watch this tooth overnight. Now it's time to check our results. Let's see how much of this tooth is left. And here it is. It looks much smaller. To figure out exactly how much smaller, let's compare it to the before tooth. As you can see, the crown is almost entirely gone, and the roots are much, much smaller. Now all that's left is to weigh our tooth and get our final results. In 40% hydrochloric acid, our tooth decayed by over 70%. That means it's less than 1/3 the size it was before. Wow, hydrochloric acid. Pretty intense and scary. But did you know you actually have some hydrochloric acid with you right now? Yeah, in your tummy. That's right, hydrochloric acid is one of the main components of stomach acid that our bodies use to break down the food that we eat. But don't worry, your stomach lining protects the rest of your body from this dangerous acid. Just, try not to swallow any of your teeth.
Leave them under your pillow instead, where they belong. Tooth Fairy away!
So thank you, thank you, Mitch and Asa, for the science demonstration there, and a wonderful way to see the effects and impacts of acidic conditions on our own bodies. So this natural condition that we see here in Dalal, Ethiopia, is something that can be reproduced in the laboratory, but it's an extremely unusual place on the surface of the Earth. We're going to continue our travels And Asa, maybe we'll back up from Ethiopia here, so you'll see the color there in Dalol. We're going to be backing up, and you'll see the context in the Afar Depression of Ethiopia and Eritrea. And you'll see that we're leaving the Rift Valley. We're up at satellite level now. You see the Red Sea to the north, the Gulf of Aden down to the south, and you've got the Arabian Peninsula. Then you can see the Persian Gulf, and we're going to be crossing the Persian Gulf, and we're going to go to the subcontinent of Asia. And we've got the Tibetan Plateau is the great big sort of oval brown area. It has a beautiful mountain range on the southern side, which I'll invite you to tell me the name of the mountain range. The highest mountains in the world are here. And we're going to go to northern Pakistan, and we're going to look in the mountains of northern Pakistan for one of the most exciting peaks, one of the hardest peaks in the world to climb. And we're going to be coming right down in northern Pakistan. And I've spent a lot of time in Pakistan. I did my dissertation work here, and I was back just a couple of years ago giving talks on climate change in Pakistan. But we're going to be coming down into an area that's right near the border between China and Pakistan and India. And I'm still waiting for the mountain range to show up, but I'll tell you the answer in a moment. But we're looking here, these very high mountains are, they have glaciers on all sides, and the mountain range is called the Himalaya Mountains. And we're looking at a small subset here right on the border between Pakistan, China, and India. And the mountain that we're looking at is called K2. And it's thought to be the second highest mountain in the world. And it's extremely difficult to climb because it's so remote and it's so steep. You can see it's almost pyramid shaped. And so to climb up to the top, you've got to go up very steep rock walls, and the access takes a long time. It's super hard to get there. This region has been written about in a book called 3 Cups of Tea. If you'd like to read a book about this area, it's a wonderful story about a mountain climber who got lost on his way down and ended up building schools for girls. The book is called 3 Cups of Tea. And this is K2, and the glaciers are the rivers of ice that are feeding off of the mountain in all directions. So a wonderful, dramatic view of one of the most extreme areas in the world, the high Himalayas over in the northern part of Pakistan. We're going to continue our tour, and we're going to go towards the east. We're going to go along the northern border of Nepal and Tibet. And I'm going to show you a place that I've been to on the ground near Lake Manasarowar and Lake Raksas Tal. So we're going to get back up to satellite level. We're going to climb up. We're at high airplane level now. We're going to go above high airplane. Now we're up at satellite level, and we're going to be crossing towards the east. So we're moving along the southern fringe of the Tibetan Plateau, and there's a couple of lakes that are just coming into view. We've got Nepal on the right. We've got Tibet on the left. And then these 2 lakes are very famous lakes. They're sacred to the Buddhist and the Hindu people. And part of the reason why the lakes are so sacred is because they're near the most sacred mountain of all for those people, and that's Mount Kailas. And a few years ago, a friend and I walked from the bottom of the screen, and we walked up around the left-hand side of the left lake, and we walked up to Mount Kailas, and we walked around Mount Kailas, and then we came back down, we walked around the lake on the right, which is Lake Manasarowar, and then we walked on back into Nepal. It took about a month of walking, but we had our baggages being carried by ponies, and then we got to high altitude, the baggages were carried by yaks. And we can zoom in a little bit here, Asa, and just to the north of those lakes in that mountain range, not very exciting looking, but Mount Kailas is the name of the mountain, and it's this very sacred mountain to the people of South Asia, and they go on pilgrimage to see this mountain. And for us, it's a sharp peak in there, right about the center of the screen, a little bit on the left, and right about there, yeah. And it's got a beautiful shape. It's shaped like a pyramid. It's made of conglomerate, which is a kind of rock made of pebbles, and it's the most magnificent feature to see. And it was a wonderful pleasure to be able to go on that trip to see it. I think it's actually the one on the left-hand side of the screen. It's got snow on it. I said right there, and it stands up as a pyramid by itself. And you go on pilgrimage by walking up that valley on the left and around to the top, and then back down on the right. And it's a fantastic view. And it's layered sedimentary rock lifted up by the force of plate collision, which is what is characteristic of this part of the Himalaya Mountains. So a wonderful view, and it was just a spectacular trip and a wonderful thing. This is the area, we had yaks here, and the yaks knew the trail. We'd follow the yaks, and they didn't need any guidance. There was a trail, they'd been on the trail before, and you just follow the yak. And the yak carries your potatoes. And the potatoes are very important because you're always hungry. And at night you boil the potatoes, and it's a wonderful to have a meal of hot potatoes up in these mountains. And without the yak, you'd have a hard time carrying enough potatoes. So yaks are very, very helpful here. But let's back out, and we're now going to go and again in the context of extremes, we're going to see if we can find the highest mountain of all. And I invite you guys to put the name of the highest mountain in the world in the chat. I'm sure many of you know it. It's over 29,000 feet high, and it's located on the border between Tibet and Nepal. There you go. I see Emily's got it right. Emily's got it, and Carlotta has it. Pam's got it. Good for you. Good for you. And we're going to go right now. We're going to go down to the border, just to the little bit to the right, and there's a sort of a range of mountains here that's shaped a little bit like a croissant, right in the central part of the screen. And again, you guys can look for this on Google Earth. You'll find it on Google Earth. And we're going to go into that croissant-shaped piece of mountains right there at the central part of the bottom screen. And we'll see if we can find the highest mountain in the world. So we're going to be zooming in. We're still at spacecraft level here, but we're getting down to almost to high airplane level here. As we get down to high airplane level, it'll start to show up as a peak. You'll also notice the glaciers that are very active in this area. There's rivers of ice that are flowing off of the highest mountains in the world. And as we get in a little bit closer, you'll see that the rivers of ice are flowing down valleys, and they're cutting and carving the rock and carrying the debris down into the basin floor. As we get in a little bit closer, you can see there's rock slides. The slopes are extremely steep and rugged, and it's a very dangerous place for climbers because the rocks are unstable. The rocks are moving all the time, and it's a tricky place to get around in. We're coming in here, and you can see that the glaciers, oh, look at this. Here's the view from the ground. Asa's brought us right down to ground level, and you can see the glaciers coming down off the mountains, melting at their toes, and there's meltwater lake there in the foreground. It's sort of muddy water. But it's one of the things that's happening today in the region of the Himalayas as the glaciers are melting because of global warming. We're accumulating more and more of this meltwater. And every once in a while, the meltwater lakes overflow, and they can create catastrophic floods in the valleys below. So it's one of the hazards associated with global warming in the high mountains of the Himalayas. The other thing you can see here is how rugged it is. The climbers are climbing up on the side of Mount Everest here, and you can see that it's very steep. And you can also notice that the rocks, there's some yellow stripes I think you might see on the rocks on the left-hand side of the screen. And those are sedimentary rocks. The rocks of the very highest mountains here are made of sediments, and the sediments have fossils in them. And if you look closely at the sedimentary rocks on Mount Everest, you can find fossil seashells. And the evidence is clear that these rocks that today are right on top of the highest peaks at one point were below sea level. And the reason for all of that is because of the collision of India with South Asia, and the creation of the Himalaya Mountains lifted up the sediments that had been in the ocean and put them up at over 29,000 feet of elevation. It's a wonderful story, and it's a story about how dynamic the Earth is. So we're going to continue with our quest for extremes, and I want to bring you back to the United States. So we're going to leave the Mount Everest area, and we're going to hop back up into our spaceship and get our satellite view, and we're going to cross away from South Asia and see if we can't find Western North America. And I want to take you to one of the most extreme places we have in the United States, a place that, again, you guys might be able to visit because it's not all that far from Colorado, for those of you who live in Colorado. And if you live in the western part of North America, you can get to this place pretty easily as well. So I'm going to be taking you to the place that's the hottest place in the United States. It's also the lowest place topographically in the United States. And let's see if some of you might be able to guess where we're headed. And it's a valley, and it's in California. Yeah, there you go. So Neva has it just right, and so does Emily. Good for you. We're going to cross, we're crossing to the east, we're crossing Southeast Asia, we're crossing China, we're crossing Taiwan, we're crossing Japan, we're crossing a great big ocean. There you go. Liv's got it right, Carlotta's got it right, and we're headed towards Death Valley. We're crossing the Pacific Ocean. We've crossed the islands of Hawaii. You can see Southern California, Baja California, the Gulf of California coming into view. And we're going to be zooming in into southernmost California, right on the border with Nevada. So the state line between Nevada and California is very near where we're going. And this is an area that we call the Basin and Range, part of the Western United States. It's made of a whole series of mountain ranges and valleys. And the deepest valley is called Death Valley. And Death Valley is below sea level. It's 280 feet below sea level. So if the ocean were to flood in here, you would have a branch of the ocean in this part of Southern California. But this is Death Valley, magnificent place to see. It's a national park also, and you can get here if you live in the Western US without too much trouble, and you can see one of the most extreme places on Earth. It's below sea level. It's one of the hottest places. The temperature's been recorded up to 130 degrees Fahrenheit this last summer. One of the hottest places, perhaps the hottest place on Earth. And we're going to come here to Dante's View, which is a wonderful overview because you're high up above the valley. It's not too hot here at Dante's View, and you can look down across and see what Death Valley looks like from a distance. Here you're looking down across the whole valley, and Ace has put us right on the ground. And you can see down to the bottom of the valley. It's called Devil's Golf Course, and there's a place there called Badwater, where there's a spring full of very salty water, and you can stick your tongue in it and taste it. It's super salty. And then you can look up along the length of the valley, and there's a wonderful visitor center in the National Park headquarters, and I encourage you to travel here. It's a wonderful place to see. The geology, of course, is magnificent. The faulting is very active. There are earthquakes frequently, and you can get a feeling for the earth being pulled apart, similar to the African rift system in many ways, actually. So we're going to see if we can get right down onto the valley floor. I think we've got a photograph of what it might look like on the very floor of the valley. There we go. Again, there's a boardwalk. You can walk out there safely. And here you can step off the boardwalk if you want. The ground is solid, but it does have a lot of salt there. And you might want to have some hiking shoes, but you can walk around out there. And this is it's called a Playa Lake, and it's filled with sedimentary rocks, and the sedimentary rocks have a lot of salt, and the salt is in the water, and as the water evaporates, you get white sandy deposits of salt. Again, you can lick it with your tongue and you'll taste the salt. So here we are. This is the floor of Death Valley, the very extreme spot in the United States, the lowest part of the United States, the hottest part of the United States, and a place that I encourage you all to take a look at sometime and visit. So we've seen the super hot place. I might ask you about super cold. Where do you think it might be super cold? And we're gonna have to get Asa to fly us there, so he'll have to back out again till we get up to satellite level. We're just about there at satellite level now, high airplane to satellite. And then as we go up into even higher satellite level, we'll start to see the western part of the United States come into view, partly because you'll see California. That's Lake Mead on the right, California on the left, the Channel Islands, Salton Sea, and there's the Gulf of California and Baja California and Mexico. We're going to go south of Mexico across Central America, and I'm going to continue south. And so you can think of where we might be going. There's the Andes Mountains on the western side of South America, and there's this giant white continent at the southern extreme part of the Earth, and that is the continent. There you go. You're getting it. Emily's got it. It's Antarctica. And we just wanted to show you what the coldest part of the world looks like. Antarctica is by far the coldest. It's been measured to minus 129 degrees Fahrenheit in Antarctica. And we've got people who spend all year down there doing research. And they do research on the penguins. They do research on the biology of the Antarctic Ocean. They also, of course, do research on the geology. And there's a volcano in Antarctica named Mount Erebus. They study that. And there's also, of course, lots of ice. And we have huge studies of the ice of Antarctica. And people are studying the ice sheets. They're looking at how global warming is affecting the ice sheets in Antarctica. And there's a concern that the melting ice sheets in Antarctica, as they come off into the ocean, will cause sea level to rise at unusual rates. So the climate scientists are very carefully watching Antarctica. And you can see what the research stations look like. It looks a little bit severe to me. You live in a trailer like that, and it's super cold outside. The vertical buildings are the drilling rigs where they're drilling into the ice to get records of the ice cores. And I think we've got another picture of McMurdo Sound, which is on the coast. And it's a place where people do spend the year. They overwinter down there. Of course, it's super cold and dark in the wintertime, but they live in these research buildings. And I've got friends here from Denver who've spent time down in Antarctica working at McMurdo Sound. So a very inhospitable place here at the southern extreme of our planet. And as we talked about the planet and extremes, Asa, we might use the capability that you have to actually put the planet in a perspective by going up to even higher elevations and higher altitudes. So what we're going to do now is we're going to back up to satellite elevation views of the planet, and then we're going to go even further. So hang on tight, because this is going to be a very dramatic expedition. We're leaving the surface of the planet, and we're going to see how the planet sits, what's next to it, what its context is in the solar system. And as we back away from planet Earth, we'll be seeing the sun over there. We've gone on beyond the moon, and pretty soon we're going to see the orbits of the planets, the trajectories of the planets around the sun. And they, of course, are ellipses, which are almost like circles, but they're like elongated circles. And our planet is the third one from the sun. And so you can count the rings out. So we're at the end of that blue ellipse. And then the outer gas giants are showing up. The trajectory of the gas giants, Neptune, Jupiter, Uranus are showing up. And we're going to continue out even beyond the solar system, because we want to show you how extremely far humans have reached. And we've got the trajectory of the Voyager spacecraft on, and those yellow lines that are stretching out beyond our solar system are the location of the two Voyager satellites. And they are the furthest traveled man-made vehicles that have been launched away from our planet. And they're about 15 billion miles from the surface of the Earth. They've traveled a long, long way, and they're continuing to travel out into outer space. And they have messages on the Voyagers. There's a message. If any life form intercepts those satellites, they'll find a golden tablet on the side of the spacecraft with a message from planet Earth. As we continue even further out, we're leaving the Earth and the solar system behind. We've got another signal that we sent from the Earth, which is in the form of radio waves. And when we first invented radios, strong radios back in the 1950s, the middle 50s, we were broadcasting radio signals out into the world, but they went out into space as well. And here you can see the sphere of those radio wave signals that have traveled out from the Earth into distant reaches of outer space. They've been traveling now for 75, 80, 90 years. And so they travel at the speed of light. And so the distance, or the diameter, or the radius actually of the sphere would be on the order of 70 or 80 light years, just to give you a sense of how big it is. And within this distance, we've been discovering that there are other stars that have planets around them. And I think we can turn on the Exoplanet Data Set, and each of these blue circles represents a possible planet around another star. And you can see that the radio signals from the Earth are getting out far enough that they're encountering these other exoplanets, which are planets that are circling other stars, and we don't know, but perhaps on one of those planets there might be somebody listening, and they might start hearing our radio transmissions from the planet Earth. That could be happening right now. It would take a long time for them to send us a signal back, but maybe that will happen someday. So we're going to try to wrap up. We've got about 10 more minutes. Anybody that needs to leave, of course, we understand that, but we can spend 10 minutes or so with you. If there are any questions, if anybody wants to raise any issues, we can put that in the chat and we can answer your questions on our presentation here. And I'd like to thank you all for your participation, people from Alaska to Hawaii to Washington to New York City and everywhere in between, especially Colorado. We'd like to thank you all for participating today. And let's see if we have some, maybe some questions, if anything's come up. Mitch?
And we do, yeah, we have several questions. The first one is, people are a little worried that Yellowstone is a volcano. Is it going to explode?
Well, so we ran a field trip from the Denver Museum a few years ago, and the title of the trip was Let's Go to Yellowstone Before Yellowstone Comes to Us. And so the answer is yes. As a geologist, I will tell you that Yellowstone is a volcano that is asleep, and someday it will wake up. But the evidence that we see is that it's pretty soundly asleep, and it may be thousands and thousands of years before it wakes up. So it does have the potential to have a very large volcanic eruption, definitely, but it's likely to be thousands of years in the future. We don't expect anything very soon from Yellowstone.
Okay, good. Glad to hear it. And then we have another question about, I believe it was this desert behind me right now. If it's so hot, why hasn't all the water evaporated?
Well, that's a very good question, and I'll answer it from the standpoint of Lake Turkana, where I've just been, which is often said to be the largest lake in a desert on Earth. And the reason why there's water in Lake Turkana is, you're right, it's evaporating very quickly. It's super, super hot. It is so hot, and that water definitely is evaporating. But there's a river called the Omo River that comes from Ethiopia, and it flows into Lake Turkana. And if the river did not flow into Lake Turkana, we've done the arithmetic, and Lake Turkana would dry up in a matter of 10 or 15 years. So you're absolutely right. The evaporation forces are very strong, but it's because there's a feed of water into these areas from outside the desert that allows those lakes to continue to be there.
Ah. And another question about deserts, how hot is it in Death Valley?
Well, Death Valley it's super hot. I've been there doing field work, and we actually work in the wintertime. And a friend of mine, we'd figure out when the full moon was going to be, and we'd study the rocks until it got dark, and then we'd wait for the moon to rise, and we'd walk back in the dark, because you walk a long way from the car, because the road system in Death Valley is being curtailed because they want the park to be natural. So you can't just drive everywhere. So we would get as far as we could by car, and then we'd do our geology work in the it was still hot even in the winter, but then we'd walk home to the car in the dark by moonlight. And Death Valley gets up to 130 degrees Fahrenheit. It is super, super hot.
Nice. And I actually looked it up. Right now in Death Valley, it's about 74 degrees Fahrenheit, which is not bad.
So
But
this
the
would
record,
this would be a perfect time to work there. So
yeah. But the record temperature is 134 degrees Fahrenheit, recorded back in 1913.
there you go.
So here's a good history of the Earth question. Have these deserts always been so hot?
Well, that's a question that we ask a lot. And for example, at Lake Turkana, where I was just working, we look at the fossils of the animals, and we learn from the fossils what kinds of animals lived there in the past. And many of the animals which we have fossils of were animals that were adapted to live in deserts. So Lake Turkana has probably been a desert for a very long time, millions of years, but the animals were able to live down near the lake shore where they could get water and where there was vegetation, and the landscape around them might have been very similar to what it is today, which is a super hot desert. So we see animals that are adapted to living in the desert. And I used to ask the question, I'd look at the zebra around Lake Turkana, and the zebra are super fat. They just look wonderfully fat. And it's so hot. And I said, well, how is it possible those zebra can be so fat when it's so hot? And my advisors would tell me, they say, well, these animals evolved in this landscape. It's their natural condition. It's their home. And so the zebras have adapted. And of course, it's super hot, but they live in super hot conditions. And there's plenty of food around for the zebras. So they're nice and fat. Life is good.
All right. And now we have several questions. What's the difference between day and night in a desert? How much does it cool down at night?
Well, I'll tell you another story about that. I was traveling from Sudan to Egypt one time, and I was traveling discount. I had a discount ticket on the train because I was a student. So I had student discount, and I was there with some Egyptian students, and it was super crowded in the train and super hot. So they said, let's go up onto the roof. So we went up onto the roof of the train. We just climbed up onto the roof, and the train wasn't going all that fast, but they said, you got to be really careful, because if your shoe falls off, it's going to go into the Sahara Desert and you'll never get your shoe back. So I was very careful with my shoes. And then it got time to go to sleep. And so we said, well, you got to sleep crossways on the train so you don't roll off. If you sleep long ways, you might roll off into the desert and they'll never find your body. So sleep crossways on the train. So we got ourselves sleeping crossways on the train, and it got dark, and then it got cold. And it got really cold. I have to tell you that in the desert at night, it can get super cold. And we were freezing our butts off on the top of that train. And I was wrapped up in a little blanket I had from Ethiopia. And I mostly stayed awake because I was so cold. And then in the morning, the sun started to come up, and I said, well, now I'm going to get warm. But the sun was in this sort of dust zone, and there was no warmth and no warmth. And it got brighter. The sun got brighter, and there was no warmth. And then the sun got above the dust, and it came piercing right down to us sitting on top of that train, and we started to roast. So we went from freezing to roasting, riding the train from Sudan to Egypt. Wonderful story.
Oh, so why is that? Why are the temperatures so extreme?
Well, that's because there's very low humidity, and the sun is the source of energy is the sun. And when the sun is not shining, the earth radiates its thermal energy into space. And because there's very low humidity, the earth is very effective and efficient at radiating its energy, and it gets colder. And conversely, when the sun gets high above the dust zone, it shines straight down on you. There's very little cloud cover, and there's very little moisture in the intervening air, and it roasts you like you're in an oven.
Wow. All right. And now we have a question I'm curious the answer to. How many places have you traveled?
Well, I've traveled to a lot of places as a geologist. One of the wonderful things about doing geology is you get to travel to lots of places. I did my thesis, as I say, in Pakistan. I'm still working in Africa. But there's wonderful places right here in the United States and right here in Colorado. And some of my favorite places are right here, right nearby. And one of my favorite places is where Asa is just taking us back to here, which is the Denver Museum of Nature and Science. And I invite all of you to travel to the Denver Museum and come and visit us. And we've got beautiful displays and wonderful things to see, IMAX Theater, Planetarium. And I invite you all to come and see us here at the Denver Museum in downtown Denver, Colorado.
Wonderful. And that's about the time that we have. We have some people that we'd like to thank up here on the screen, people who helped us with data visualizations and things like that. And any final thoughts today, Bob?
Well, I just want to stress that we all live on the earth. I see a question about patterns and different kinds of patterns. And I think that geology allows me to study the earth, but all of us can enjoy the patterns of the earth. All of us can enjoy the features that we see as we travel around the world. And I really encourage everybody to get outside and to look around and see what you see in your own neighborhood, in your own country, in your own area. And you can study the animals, you can study the plants, you can study the rocks, You can study the climate. And I encourage you to do that. I mean, it's our world, and it's the most magnificent place. We've shown you some of the extreme places today, but there are many, many places that are so beautiful and nice to enjoy. So I would encourage all of you to get outside, enjoy the world, and thank you for visiting with us today.
Yeah, thank you so much, everyone. And we will be back April 12th with a program on volcanoes. So we hope that you'll join us again, and we hope you have a wonderful rest of your day.